Hi Pookies, and welcome to the Off-Brand Khan Academy. Today we're going to be talking about scatterplot and correlations, and this is by Caitlin, Delilah, Maria, Tatiana, and Richard. Scatterplot. Scatterplot is a graph of the ordered pairs x, y of numbers consisting of the independent variable x and the dependent variable y. The scatterplot is used to determine the relationship between the two variables x and y. Correlation coefficient. Correlation coefficient to determine the strength of the linear relationship between two variables. Assumption for the correlation coefficient. The sample is a random sample. The data pairs fall approximately on a straight line and are measured at the interval or ratio level. The variables have a bivariate normal distribution, meaning that given any specific value of x, the y values are normally distributed, and given any specific value of y, the x values are normally distributed. Linear correlation coefficient. Linear correlation coefficient, computed from the sample data, measures the strength and direction of a linear relationship between two quantitative variables. The symbol for sample correlation coefficient is R. Properties of linear correlation coefficient. The correlation coefficient is a unitless measure. The value of R will always be between -1 and 1 inclusively. That is, -1 is less than or equal to R, less than or equal to 1. If the values of x and y are interchanged, the value of R will be unchanged. If the values of x and y are converted to a different scale, the value of R will be unchanged. If the value of R is sensitive to outliers and can change dramatically if they are present in the data.
The rounding rule for correlation coefficient. Round the value of R to 3 decimal places. To make a decision, you will need to use a hypothesis testing procedure. And the steps in this procedure are 1. State the hypothesis. 2. Find the critical value. 3. Compute the test value. 4. Make the decision. 5. Summarize the results. This is our correlation coefficient example. When given or created a scatterplot, transfer the data into a data chart separating the x and y values. So we were given the scatterplot and we transferred it into a data chart. So now using the data chart, we have the x and y value, and we're just going to find the sum of each column, which is xy, x squared, y squared, and then the sum of all the values in the x and y. And then we'll be able to plug in all those values into our formula for the correlation coefficient and get our answer, which is -0.944.
Assumptions for testing the significance of the linear correlation coefficient. The data are quantitative and are obtained from a simple random sample. The scatterplot shows that the data are approximately linearly related. There are no outliers in the data. The variables x and y must come from normally distributed populations. In hypothesis testing, one of these is true. HO rho equals 0. This null hypothesis means that there is no correlation between the x and y variables in the population. H1 rho is not equal to 0. This alternative hypothesis means that there is a significant.
T-test for our example. Using the same process from before, find R, and obviously you have the sum of x, sum of y, sum of xy, sum of xy, x squared, sum of y squared, and you just plug it all into the formula and you get 0.982.
T-test for our example. Then you can use the guidelines as mentioned before to make a decision. Note that the most significant tests for correlation coefficients are generally two-tailed. However, in some instances, it can be one-tailed. An example of this would be when a researcher hypothesizes a positive linear relationship between two variables. The hypothesis is rho equals 0 or rho is greater than 0. Example 2. When a researcher hypothesizes a negative linear relationship between two variables, the hypothesis is rho equals 0 and rho is less than 0.
So this is just a continuation from the last problem. We're going to state our hypotheses, which is null hypothesis, rho equals 0, and alternative hypothesis, rho does not equal 0. We found the critical value when the significance level is 0.05 and the degrees of freedom are 4, which is -2.776 and +2.776. And then we're just going to plug in our values from before, our R value, into the T formula and compare it in relation to the critical value. And we get 10.398. We are going to reject the null hypothesis because the test value falls within the critical region. To summarize, there is a significant relationship between CARS X and revenue Y. Correlation coefficient, mung bean germination and pH levels. A scatterplot can be used to demonstrate the relationship between the pH and how many mung beans sprouted. This table demonstrates the pH level and how many mung beans ended up being germinated. And this relates to the video that we watched in class. We have the pH levels and then how many of the mung beans out of 50 were germinated. And we have all the pH levels that were tested. That's going to be our X value, and germinated mung beans are going to be our Y value. So now we're just continuing with this, and we have all our values to the right. N equals 8, the sum of X equals 44, the sum of Y is 99, the sum of X times Y is 635, the sum of X squared is 284, the sum of Y squared is 232,250. And then we just plug that in to our correlation coefficient formula, and we get 0.02905. And this value implies that there's a weak positive correlation because 0.3 is greater than 0.02905, but 0.02905 is greater than 0.
How scatterplots and correlation relate to public health. Public health focuses on preventing disease and promoting health. Scatterplots are used to demonstrate the correlation or lack thereof between two variables. An example could be how many calories are consumed by an American adult daily and their sodium intake. It provides researchers the opportunity to investigate two variables that are hard to experiment in a lab. This could assist with finding new information to use for more health improvements. Going back to the calorie and sodium intake example, this could certainly help public health professionals on an individual and nationwide scale. Professionals can use this information to bring awareness to the public, especially those that are at risk or it could benefit.